Regular expressions in Python. This is one of my favorite things to talk about since I can relate to it being a lover of language. In this one, you'll learn about regular expressions, meta characters and matches, functions, group extraction, the find all function, various options, greedy and non-greedy searching, and substitution. We'll take some examples along the way. First things first, what is a regular expression? It's nothing but a sequence of characters that helps define a search pattern. If you've ever used the find and replace feature of Microsoft Word, you're familiar with how this is supposed to work. But this is more than just that. These are great for a lot of things. In search engines, for finding and replacing, for processing text, and for performing lexical analysis. Let's import the RE module for this. A regular expression is made of two things, characters and meta characters. While regular characters are for matching themselves, meta characters rather tell us something about what to do with these characters. This is the list of meta characters we have here. A caret matches the start of a string. A period matches a single character. Square brackets match a single character from the characters within them. A caret inside square brackets matches single characters but not those within the brackets. Parentheses match a marked sub-expression. /t/n/r and /f match tabs, new lines, return, and form feed. The clean star matches an expression 0 or more times. M and n in curly braces matches the expression at least m times and at most n times. And simply m in curly braces matches it exactly m times. The question mark greedily matches the expression 0 or 1 times. Plus greedily matches it 1 or more times. The pipe matches expression A or B while short-circuiting. \w matches an alphanumeric character. \b matches boundaries between word and non-word characters. \s matches white space characters. \d matches digits. A backslash escapes special characters. And a dollar matches the end of a string. Pause your screen and let it sink in. When can we say that we have a match? We have 3 rules for this. The search should scan the entire string and not just a part of it. A match for the pattern must exist in the string, but it doesn't have to be the entire string that matches. Thirdly, the search should stop at the first match and not search further. Let's search for the string them in the string theirs. Them isn't a part of the string theirs. But is it a part of the string themselves? Yes, it is. From index 0 to index 3, which is 4 minus 1. This is a match object it returned. Let's talk about all the functions it supports. Like search, the match function takes a pattern and a string. If they match at the beginning of the string, it returns the match. Otherwise, it returns none. Is meter a part of meter? No. Let's break down this regex. The first 2 letters can be anything. The third must be an alphanumeric character. The fourth is the letter R. And the fifth can be E or O. Is such a pattern present in the string meter? Yes, it is. From index 0 to 4. And the match is meter. Search again. Match only checks for a match at the beginning of the string, but search checks anywhere. Meow is indeed present in the string homeowner, but not at the beginning. But unlike match, search gives us a positive result. The group function returns the part of the string where there was a match. A and then A 0 or more times. Yes, there's a match. This one also says there can be 0 or 1 I at the end of the match. So Ayush from Ayushman is found and the search halts. P. Some characters 0 or 1 times. AR and 0 or more alphanumeric characters at the end. This matches with the word partridge. But in the string a cartridge in a pear tree, it matches with the word pear. And if we change pear to bear, it matches with nothing. So we get a none type object. Calling the group function on this raises an attribute error. An alphanumeric character, a space, and another alphanumeric character. This matches with R space E. One or more alphanumeric characters up to 2 C's and 0 or more alphanumeric characters. This matches with the word Occam and stops at the apostrophe. Let's build a regular expression that recognizes email addresses. Let's see the solution first, then break it apart. This regex searches for this pattern in this string and finds this email address in it. This is for one or more alphanumeric characters, periods, and or hyphens. If we used a hyphen before a period here, it would mean a range and raise an error. This is for the at character. This is for one or more alphanumeric characters or a hyphen. Then a period. Escape it with a backslash, else it will consider any character at its place. And then one or more alphanumeric characters. And this is how it successfully recognizes email addresses. Like slicing a list, we may only want part of a match. If we divide the pattern into groups using parentheses, we can do this. As you can see, we've divided this pattern into 3 groups. One for the part before the at symbol, one for after it and before the period, and one for after the period. Group returns the entire match. Group of 1 returns the first part, that is info. Group of 2 returns the second, that's data flare. And group of 3 returns the third part, that's training. In the beginning of this session, we said that search stops at the first match, but find all returns all matches. In the sentence, please advise her to keep to her advices, the pattern matches 2 words, advise and advice. We can also run this on files. We have a file shoppinglist.txt. Let's import OS and open this file. This for loop reads the file and prints all matches for this pattern. It matches this with the words bread and breadsticks. So you see, we can use regular expressions to deal with files as well. The last 2 things we studied were group extraction and find all. How about combining the 2? This is the string. Look for this pattern of 2 groups and return the match. The date can be 1 to 2 digit long. Then there's a space, and then there are 0 or more alphanumeric characters. This gives us 4 tuples for the dates. All the functions we discussed so far may take an optional argument. If we use ignore case, it matches without comparing cases. Look for hi in hi, did you ship it, Hillary? Pay attention to the ignore case option. Can you see the statement has 3 highs? If we choose to go multi-line, the caret and dollar signs also match the start and end of each line instead of doing that just for the entire string. In this one, Hillary replies, since we had a caret in the pattern and the multi-line option, This checks the beginning of each line for a high. Another option is .all. Normally, an asterisk after a period would only match until a new line character, but with this option it matches everything, all lines. Let's do this one, and it matches the entire thing. Some meta characters are greedy. They keep searching for more. These are the asterisk and plus signs. This pattern matches angular brackets and 0 or more alphanumeric characters between them. The clean star is a greedy quantifier, so it keeps matching until the last closing angular bracket. This gives us the entire thing. Let's add a question mark in front of this. This is a non-greedy modifier suffix. This makes it non-greedy, so matches 4 items. Finally, let's talk about substitution. With the sub function, we can replace a matched pattern with a substring in a string. If the string begins with an A and 0 or 1 N, which means that if it begins with an A or with an, replace this with the. If it begins with A or an and a space, replace it with the and a space. So both a apple and an apple become the apple. Interesting. What is your favorite thing about regular expressions? I'm Ayushi Sharma. Let's talk in the discussion forum. If you see me, say hi.